Okay, now again, physics predicts that the frequency ought to be some number divided by the square root of the length. Okay?
All right.
So, if that's true, then, well, we have a frequency here and a length here that we could plug in and get A, right?
Yeah.
Where A is just a number that we have to determine. It's called a parameter, okay? So I could write down A is a constant number to be determined. And I'll say A is a parameter of the model. Okay, just a terminology that you need to understand, that you need to recognize when you see it. So kind of pay attention to that use of the term parameter. Well, okay, if I plug in these numbers, doing these numbers in my head, I got 590 and 580, two different values of A, but pretty close, right? Using your calculators, which as I said, you need to check out because they didn't agree with what I did in my head, you got like 600 and 590, okay? Make sense? Well, that's pretty good consistency. Not between my head and your calculators, as I say, you need to check those things out, but between our two observations, which tells me that we did a pretty good job, especially of measuring these things, because I did that. Y'all did a really good job of counting these. Okay, you were consistent in your count, we went to the median, and we got really good results. Okay? So that's kind of impressive. So now we know the rule. Now, we don't know whether you use 590 or 580. Well, they average out your results, and they average out pretty close to 590. Okay? So, our tentative model F is approximately 590 over the square root of L, where F is in half cycles and L is in centimeters. Now there are things we can do with units in this thing. I don't want to confuse the issue yet with units, but we're going to develop that. Okay?